Hello, quick video on correlation coefficients and hypothesis testing in the MEI S2 syllabus. I'm going to use the January 2011 question 1 as an example. This question is worked on the basis of summary stats and then doing all the calculations from there. So let's start off by reading the question. The scatter diagram below shows the birth rates and death rates measured in standard units in random 14 countries in a particular year, and summary statistics are set out there. Okay, calculate the sample product moment correlation coefficient. So here we go. We're going to off and we're going to need our formulae. So let's get those from the MEI tables. So on page 6 of the tables, we can find the product moment correlation coefficient R and the formula for calculating it. So this is we're going to use this end because those are the values that they've given us. So let's pick those out and fill in the formula. So sigma of x of y, sigma of x squared. Let's start off actually by finding our mean values, x bar and y bar, shall we? So looking at the top here, sum of x is 1389 and sum of y is 1404. So transferring those numbers down to here, we've got 139.8 divided by 14 equals, that's 9.99. So leave it at that for three significant figures, and the other one is 140.4 divided 14 is 10.0. Okay, so there's our first two facts that we need, and we can use those now in the next part of the calculation. So R equals sum of xy over n and x bar y bar. So let's have a look at that. Sum of xy over n is 1398.56. 1398.56 over 14 minus 9.9 times 10.0, and the whole of that is going to be divided by this horror bag here. So let's work that out. That's going to be, so we need the sigma x squared 1411.66. Here we go, 1411.66 over 14 minus x bar was 9.99 all squared, and in the second bracket is the sum of y squared, which is sum of y squared 1.147.88. 1.1488. Let's just check that over 14 minus 10.0 squared. Let's just check. I might transcribe that number incorrectly. 1.1417 rather than 1.144. So let's just correct that. 17. There we go. 17. So that's the calculation, and if we put that into our calculator, we get minus 0.276. So that's our R value. That's our first part of the question. Okay, let's look at the next part of the question. Carry out a hypothesis test, 5% significance level, to determine whether there is any correlation between birth rates and death rates. Okay. So part 2, we're doing a hypothesis test, and it's asking us about any correlation between birth rates and death rates. Birth rates and death rates, yeah. Okay, so what do we start with then? H0 in this sort of situation, we're starting always with a correlation one, that there is no correlation. Yeah. So that's rho, that's what we use in place of r for our parameter, equals 0. H1 in this case, in context, it says any correlation, so we're going to go with H1 is any correlation. So here is rho does not equal 0. We're then looking at a two-tailed test, aren't we? Here, two-tailed test. Our test statistic, well, we've worked that already, is 0.276, and we now need our critical values, so that means we need to go to the Pearson table. Okay, and we've got our n equals 14 countries, and our critical value, because our significance level was 5%, and we've got a two-tailed test, so the critical values are going to be, therefore, just to bear in mind, 2.5%, but that's not what we're going to look up in the table. Okay, so here's our table below, and what we're interested in. We're interested in n equals 14. We've got a two-tailed test at 5%, so we're coming down the 5% column across the n equals 14 row, so we've now got our critical value. So our critical value for what we're doing is equals 0.5324. Okay, now let's start using that, and I want to create a test line, so let's create our test line. Okay, so what do we know about this? Well, we know we've got our correlation, and our correlation coefficient ranges from -1 to +1. We know that our null hypothesis is that there's no correlation, so it's there in the middle. In terms of our critical values, we've worked those out, and it's a two-tailed test, so we've got a critical value here at plus 0.5324. So our critical region on that side is going up to +1, so that's H1. And we've got a second critical region here, which is minus 0.5324. That's our second critical value, and so we've got a second critical region that goes all the way out to -1. So there's our H1. Now, what was our test statistic? Let's go back and check what we created. That was our test statistic is minus 0.276. So let's position that on our number line, and here it is. That's going to be our test statistic, isn't it? Minus 0.276. And as we can see, that's not in our critical region. So what we're going to conclude then, we're going to conclude that not significant, we're going to have H0 is accepted. Should really have written there that test statistic of minus 0.276 is greater than our critical value of minus 0.5324, shouldn't we? We've written that as well to get our points, and then we're going to write our context statement that there's insufficient evidence to conclude that there is, and what did they ask us up the top? Let's go back and reuse the wording as they asked us. Any correlation between birth rates and death rates. Any correlation between birth rates and death rates. There we go. So that's our main part of our work here, isn't it? Okay, what's the next part of the question? State the distributional assumptions that is necessary for the test to be valid. Explain briefly from the scatter diagram why it appears the assumptions may be valid. Okay, there's only one thing we have to be able to say is the bivariate and the figures, so I'm going to write that in here, bivariate, and each one is normal. Each of these has got to be normally distributed. That would result in a sort of ellipsoid relationship. Therefore, ellipsoid, if I drew something around it, extremity like I've drawn, which is what we've got. So there's 2 marks, one for saying it's bivariate normal distribution, the other one for saying that we've got an ellipsoid here. Okay, what have we got to do last in this question? Values x and y for another country are 14.4 and 7.8 respectively. This would move the correlation coefficient to 0.5694. I think the point here is if we just go back to what we did just now, that's bigger than the critical value, isn't it? That's more extreme than the critical value. Okay, explain why this one observation causes such a large change. Well, if we were to plot that point, we would have something out at 14.4, so that would be out here, wouldn't it, and 7.8. So here's a pretty extreme value for our x and y, and that's going to change our correlation coefficient because it's going to make it look like we're looking at a distribution like that, so a much longer and narrower ellipsoid, isn't it? So that's why it's distorted, really significantly changed our 0.5694 as our correlation coefficient out there and moved it into that critical region. Discuss whether this brings the validity of the test into question. So if we went back, let's just write a couple of notes here, shall we, so that we know what we're doing. This is the last part. What was that? So adding the point at 14.4, 7.8, it's well outside the range of the other 14 points, but in line with the sort of line here, and therefore it's increasing the correlation coefficient. This would mean that our R value is now in the critical region. It's changed the test result, and our ellipsoid's really become much more of a sausage, hasn't it, in that respect. Okay, as ever, here's my little summary at the end. For regression and hypothesis testing, the formulae for calculating our PMCC or R is in the formula book, page 6. For these cases of regression hypothesis testing, the H0 is always that there's no correlation, rho equals 0, and then the H1 is in context, it's either not equal to, greater than, or less than. Our test statistic is our R, our correlation coefficient, and our critical value is from our tables, and it's dependent on the number of points, the tails, and the percentage. Please do draw a test line that I've got here on the left. Please do draw the test line and put in the H0s, the H1s, and our critical values and our test statistic. And that will help you avoid making any mistakes. So there we are. I hope that video is of use.